So I have a classmate with me. She's pretty insistent that I'm gonna pay attention to her. Everybody say hi to Nova. Say hi, everybody. Hey, that's my mom. Will you please go lay down for a second so I can get over here? I know I'm on the floor. Yes, I love you very much. Go on. Hold on. All right, giving this another shot. I've got dog toys and a rock. Say hi to this painted turtle rock. I don't remember who painted it. I feel like it was me and my brothers. I know it was one of the three of us. Anyway, back up. Okay. I'm at home. I go, let you guys see. This is how I had to satisfy her. Yes. Anyway. So, okay. So we had a video session the other day on Zoom. Not very impressed with Zoom. It takes too much out of you. This is number 2 for Geometric Optics Fun Sheet number 1. Thin lenses. I'll be doing the rest of this sheet and probably into the next one and just putting it all into a playlist for you guys. But, so, for drawing, ignore the numbers for the moment. When I do these homework problems, I start with what I know. And what I know is that we're using the blue as a ground line. Duke. I use this green here as a lens. I don't know what kind of lens at the moment, but it's the lens. And then your object, which Mike suggests an arrow so that when it goes through the lens, either it's going to do its inversion or it'll be erect over here. We also do information that we know, which is that on the left side, distances are negative, and on the right side, they're positive. All right. So what we know about this question is that the given information is that the object is 20 centimeters tall. The object distance, which is u equals 40 centimeters. So object distance is 40 centimeters. And that the focal length, so focal length is when the light goes through the lens and where the image comes into focus. So focal length is going to be either on the plus side, so it's going to be a positive focal length, or it's going to be a virtual focal length. And in this case, focal length is minus 15. So this is... I didn't realize the glare was coming from behind me. I thought it was from the other window. Okay. Let's see if I can make this work. So focal length, minus 15. So focal length is going to be on the left side of the lens. Minus 15 centimeters. That's supposed to be an M. The worst at writing M's. And then, of course, we have 2F. And then 2F over here, since this is a 15, 2F is 30. So if the image distance is 40, 2F is going to fall somewhere before where the object lays. So this is 2F. This is minus 30 centimeters. This is so that you know when you're drawing it where to put your object. But yes, so normal questions, it's going to be find V, M, and I. Image distance, magnification, image size. To find V, we use minus 1 over U, which in this case, because this is the left side of the lens, it's going to be most, if not all cases, is going to be minus 40 plus 1 over V, which we don't know, which equals 1 over the focal length. In this case, it's a minus 15, so minus 15. Solving this out means that we have 1 over V equals 1 over negative 15. These two cancel out and become a positive. This is positive on this side, which means that we have to subtract that. So, and the doubled means that it's the same thing. So subtract 1/40. We have 1 over V equals I don't know. Why do I just not keep the calculator on me? Hold on. Down to the calculator becomes 1. I don't know if you can see it. Divided by 1, -15. Minus 1 divided by 40. We get a minus 0.0917. 0917. Alright, so this is where we're currently at. If we throw this one over a 1, we can cross multiply. So minus 0.0917 V equals 1. That means that V equals 1 divided by 0 minus negative 0.0917. Going back down here, 1 divided by negative 0.0917. That was not a 7. That's a 7. Boom. We get a image distance is about minus 10. This is where Mike and I differ. 9.1. He's got us rounded to about minus 11 centimeters. So depending on what he's asking, I think he wants full numbers. So our image is going to be located somewhere up here. Let me get a different color. Image is going to be up here, and it's going to be minus 11. So this is 15, 11 somewhere in here. So this is where it's going to be, somewhere in here. V equals negative 11. All right. I'm going to leave that for a second, and then come on back down. I don't know if I want to clear that yet. Actually, you know what? I'll just leave that open. I'll leave that open. Okay, so you guys can watch me erase and stuff. Oh, let me book. There we are, so you can see. You guys can watch. I really hope everybody's having an alright time at home. I know it's a little bit different. I'm getting these out of the way, and then I'll get the next homeworks in. I'm going to try and do the dispensings as well. V, image distance, is about minus 11 centimeters. Magnification, M equals image distance. Image distance, which is minus 11, over object distance, minus 40, which equals image size over object size, which I'm going to put in here already. It's going to put as 20 centimeters because we're about to use this again. So this equation is going to be used for to find both M and I. Since these are two positives or two negatives, it becomes a positive. And then 11 divided by 40 equals 0.275. So M equals 0.275. We know that now, so 0.275. And then one of the things that you could do, which is practically, it's what we are going to do. I'm going to use the same equation because it just keeps going down, equals I over 20. If you throw this over a 1, you cross multiply, boom, boom, becomes I equals 20 by 0.275, not divided by. See what I did there? I would have written that down too. It's like, but since we did this already, I know that that is very wrong. 5.5. Image size is about 5.5 centimeters. So just because it looks more complicated here, if you know the magnification and you know the object size, which is 20 centimeters, literally you're taking magnification times object. And then whatever your answer is. Answer. And in this case, it's 5.5 centimeters. 5.5 centimeters. So what does that look like in our wonderful handy dandy graph? It means that because this is a positive, wonderful. For how I do these, you guys might do these a little bit differently, but because this is positive, means that my image is going to be upright. It's going to be erect. And so when we're drawing this, what that means is that when the light hits the lens, this is a minus lens because of the negative focal distance. I forgot to say that. Means that light diverges. When it hits here. So minus lens. It's these upside down things here. And that the light goes back down. That when the light is virtualed, it goes down. And technically it goes through the focal here. I'm just not drawing this very well. That the second line goes through the optical center. And I guess that I should probably actually draw this more to scale. There we go. And so here's our wonderful handy dandy object here. Or not object, our image. It's over here on the left side of the lens because it's not projected through the lens. This image is a virtual image. It's erect. And we have a minus lens. Yes. Yep. Okay. Let me know if you have any questions.